the tangent. Alright, here we go. Let's say you have a circle, or just a curve. Now, the tangent to the circle is basically the line that touches the circle at one point and doesn't go through the circle. So for example, this would be a tangent. So would this be? Alright, it touches the circle at one point basically, and it doesn't go through the circle. So basically what it is like, if you were to make this part a straight line, what would the straight line look like? And it's a curve, so you can't quite make it straight, but let's you bend it straight, it would look like this line right here. Or if you take this point up here, bend it straight around it, it would look like that line over there. So for this curve here, this is a tangent line, right here. And so is this. Oops, sorry, that wasn't quite tangent. There. So this is a tangent line, this is a tangent line. Now, the cool thing is, it's easier to find the tangent line to certain things, but it's really hard to find the tangent line to other things. And basically, what we want to do here is, well, let's just say we want to find the tangent line here at the bottom, where it comes to like a little crest, or a little dip. The tangent line is actually y equals -1. So what's the slope of this tangent line is 0, right? Because it's horizontal. Lines and tangents, okay. So lines have slope. The slope of a line is the same between any 2 points on the line. So we can pick this point here and this point here on this tangent line, find the slope, and it'll be the same as this point here, and this point here, or this point here, and this point here, or this point here, and this point here, or any 2 points, you find the slope on the same line, it has the same slope. Now the cool thing is, okay, so this is the tangent line, the slope is 0. So at this point, the slope is 0 for the tangent line. Alright? The question is, what do you think the slope is like up here at this point for the tangent line to this parabola thing? So you got a parabola, you want to find the tangent line there. Now how do you do it? Well, one way to do it is to look at this point right here. Now, do you remember what this point was? Let's see, it's 1, 0, right? So the point, let's call this point P. Yeah, variables can stand for anything in math. They can stand for points or lines or parabolas, or they can stand for anything. So what I'm going to do is call this point P. So point P is 1, 0. Now how you find the line is really, really cool. Or how you find the what do you call it? Slope of the tangent line is really, really cool. What we're going to do is we're just take a random point on the parabola. Now a random point on this parabola has an x value that we don't know. We don't know what the x value is. So what we're going to do is we're going to give the x value a random name. And usually what they use is c for this kind of thing. So the x value at this point, we're just going to call it c because we don't have any idea what it is. Now what's the y value? The y value would be c squared minus 1 because on this parabola, c squared minus 1 is the y value for x equals c. So you just take the x equals c, plug it in, and then you get y. So c squared minus 1. Now, if we draw the line between this point and this point, that's kind of accurate, but it's not completely accurate, right? Because this isn't quite tangent. It touches the parabola at 2 points, and it's not quite the estimate that we were looking for. So, let's see. This is point Q. Or I'm going to put it here, Q. So again, point Q is c, comma c squared minus 1. Let's see, does that go under? No, still in the video. Okay, good. Alright, so Q equals c squared minus 1, p equals 1 comma 0. Okay, now we have a problem because if we find the slope between these points, we get a variable out of it, and that's a problem. So what's the slope between these 2 points? It's this minus this, which is, so m equals c squared minus 1 divided by c minus 1. Okay. Now this is a problem because we want to find, this slope here, the tangent slope, obviously isn't just a number, right? It's not going to be a bunch of different things. There's definitely one answer for this. So what are we going to do? Well, what we're going to do is we're going to bring this point close to this point. In other words, we want c to get really close to 1. So let's find out what happens when c equals, for example, 1.1. Now if c equals 1.1, let's redraw the graph here. This is kind of messy. Just kidding, right? So this is the point, this is the C point, so this is Q and this is P. Now 1.1 is pretty darn close. And what we can do here is we can plug in 1.1 for C and see what we get. So 1.1 squared, can you do that in your head? 1.21, right? Yes. 1.1 squared is 1.21 minus 1 divided by, is that out of the picture? No, not quite. Okay. So divided by 0.1. So this is equal to, let's see. This is 0.21 divided by 0.1, which is 2.1. So, we got pretty close. The slope is probably around 2.1. The problem is we want the exact answer, and that's exactly what we're looking for, the exact answer. So, what you want to do is this. You want to keep getting closer and closer and closer to 1. So we want this c to get closer and closer and closer to 1. So let's try 1.01. Let's erase this. Alright, so let's try c equals 1.01. 1.01 squared minus 1 divided by 1.01 minus 1 equals 2.01, I think. I'm pretty sure. I haven't actually done one. Let's figure it out. Yes, 2.01. So this divided by this is 2.01. As you can see, as we get closer and closer to 1, this value gets closer and closer to 2. You can try it with 1.001. You'll get 2.001 for the answer. So we're just going to say that this is equal to 2. And that's basically what you do for differentiation and limits in calculus. If you watch the next half of this video, you'll find out how to do more exact calculations rather than all this plugging in stuff that's close to 2. We're actually going to do some limit problems and other stuff like that. But this is just a basic overview of calculus. Basically what you do is you find the tangent lines to curves, and there you go.